Hello to everyone, I am Zeki Palaz. Today I will tell you about the work I have done on my graduation project. The name of my graduation project is Smartphone-based Multi-parametric glucose prediction using recurrent neural networks. This study is supported by the TÜBİTAK. My academic supervisor is Volkan Kılıç and my co-supervisor is İlhan Kaya from Vestel. I will talk about the content section on this page. In the first part, I will explain the motivation. In the second part, I will give information about diabetes. While doing the graduation project, we used bidirectional STM deep learning models. Deep learning, also known as deep structured learning, a subset of artificial intelligence, is part of a larger family of machine learning methods based on representational learning and neural networks. We did a study called Smartphone-based Multi-parametric glucose prediction using recurrent neural networks. Finally, I will explain another application called by BFF Diabetes Pro and its conclusion. Applications of machine learning algorithms in the health sectors are increasing day by day. In the health sector, machine learning-based decision support systems are used in order to obtain more accurate results in diagnosis and treatments made by doctors, to prevent human errors, and to help the doctor's decision. As shown in Figure 1, approximately 537 million people worldwide with diabetes face stuck in 100 cases, while in Turkey there are over 9 million diabetics. Turkey is the country where the most rapid increase in diabetes in Europe. According to studies, the total number of people with diabetes is predicted to increase 643 million in 2030 and 783 million in 2045. In addition, diabetes is responsible for 6.7 million deaths in 2021, which means one death every 5 seconds. This is so scary. What is diabetes? Diabetes is a disease that occurs when your blood glucose, also called blood sugar, is too high. Blood glucose is your main source of energy and comes from the food you eat. Insulin, a hormone made by the pancreas, helps glucose from food get into your cells to be used for energy. Sometimes your body doesn't make enough or any insulin or doesn't use insulin well. Glucose then stays in your blood and doesn't reach your cells. Over time, having too much glucose in your blood can cause health problems. Although diabetes has no cure, you can take steps to manage your diabetes and stay healthy. Smartphone-based multi-parametric glucose prediction using recurrent neural networks are explained on this page. In addition, studies were made on predicting glucose values by using recurrent neural networks. In addition, the study is supported by an Android application. When the flow diagram of the project shown in Figure 2 was examined, the dataset was collected first, then these data were trained with bidirectional STM, which are deep learning algorithms. Finally, these results are sent to the Android application using the Firebase Realtime database. The Ohio T1DM dataset published by Ohio University was used in the study. The dataset consists of 8 weeks of data from 12 type 1 diabetes measured in 2018 and 2020. The features given in the dataset are glucose level, finger stick, basal temperature, bolus, meal, sleep, work, stress, illness, base GSR, base step, base sleep, and acceleration, etc. This dataset is shown in Table 1. We conducted this study for 6 patients indicated in red. We used the most frequently used features for making comparisons in the literature. These are glucose level, meal, and insulin dose. A recurrent neural networks is a class of artificial neural networks where connections between nodes form a direct graph along a temporal sequence. This allows it to exhibit temporal dynamic behavior. Derived from feedforward neural networks, RNNs can use their internal state to process variable length sequence of inputs. This makes them applicable to tasks such as unsegmented connected handwriting recognition or speech recognition. General RNN structure is shown in figure 3, and a many-to-one structure shown in figure 4 was employed for multi-parametric glucose prediction. LSTMs are widely used for sequence predictions problems and have proven to be extremely effective. The reason it works so well is that LSTM can store important information from the past and forget information that is not there. LSTM fixes a major problem that recurrent neural networks suffer from: short memory. Using a series of gates, each with its own RNN, LSTM managed to retain, forget, or ignore data points based on a probabilistic model. LSTM model is shown in figure 5. Bidirectional LSTM are really just putting two independent LSTMs together. This structure allows networks to have both backward and forward information about the sequence at every time step. We used the BLSTM model in the study. Firebase Realtime database is a cloud-based NoSQL database system. They can manage with JSON parameters without the need for any SQL query. In addition to data storage, it allows instant monitoring of data chains with its asynchronous operation. As figure 7 shows, real-time synchronization makes it easy for your users to access their data from any device and helps your users collaborate with each other. As a result of the studies, these results obtained using bidirectional LSTM is as follows. The root mean square error is a frequently used measure of the difference between values predicted by a model or an estimator and the values observed. These numbers represent patient ID. Bidirectional STM RMSE value for 30 predict horizon and 60 predict horizon are given for each patient respectively. The average BLSTM RMSE value for 30 predict horizon was 17.92 and the average bidirectional STM RMSE value for 60 predict horizon was 26.52. The lowest error value was reached in patient ID 544. Bidirectional STM based on real and predict glucose levels graphs for 60 predict horizon and 30 predict horizons of patient ID 544, for whom we obtained the lowest error value, are shown respectively. The performance of the proposed system is also compared with similar studies as given in Table 2. The RMSE metrics such as 21.72, 21.40, 21.19, and 20.1 and 18.90 were reported in as Zhu, Mircherkian, Contreras, Deboy, and Li, respectively. Although the close results to the proposed system was 18.22 in Fox. Um, our system gives more minor error with 17.92, which has shown that the proposed systems outperforms the state of the art methods. Our system is then integrated with a custom-designed Android application called BFF Diabetes Pro, which transmits the current glucose level, basic temperature, and acceleration value via Firebase to the server to predict the next glucose level. These three values from the Android application are tested with our previously trained model and produce a prediction result. And this result is sent back to the Android application via Firebase. In addition, glucose level values entered by the user can be stored in our application. These glucose level values are shown in three different colors. Green is normal values, blue is limit values, 10 lower or 10 higher than normal values. Red is very high or very low values. These values may differ depending on the state of being hungry or full. This study proposed bidirectional STM-based multi-parametric glucose prediction to increase predictability before glucose level reaches critical stage. The proposed system used an bidirectional STM-based RNN to handle complex memory operations caused by multi-parametric prediction. Training and validation scores in the Ohio T1 dataset demonstrate the advantage of our proposed system over baseline system for predicting glucose level with a significantly reduced error. The RMSE value for the bidirectional STM model was obtained as 17.92 for 30 predict horizon. The system is then integrated with a customized Android application called BFF Diabetes Pro, which is transmitted the current glucose level to the server via a cloud system to predict the next level. This work was published by the European Journal of Science and Technology. Thanks for your interest.